So, hi everyone. I hope that you're doing great. I have the pleasure and honor to share with you my story, my experience about porting Doom to the browser. So, in this presentation, I hope that you will start like this. This is how I started when I made the port. Like, it was something impossible to do. I couldn't think about doing it. I don't know if you have this reaction when you think about game programming in general or and things related to that. But I hope you will, by the end of the presentation, okay, it's something that we can do. Uh, it's, uh, it's possible. So my name is Yassine. I'm a developer at Worldline. I like computer programming, and I like also video games, as you may see. So, and a quick word about Worldline. We're a payment company. We have offices here in London. But we also provide technical content via YouTube, via a technical blog, which I maintain. So please take a look. Okay, since this is a story, let's start with the prologue. So I started thinking about making the port when I heard about WebAssembly. So anyone here knows about WebAssembly? Okay, so thank you. So WebAssembly is a portable binary instruction format. It allows to run alongside JavaScript. So it was initially targeted for web browsers. And it's used, one of its main uses is to run compute-intensive tasks. Sometimes it's faster than to run it in JavaScript. But what the advantage that I see in using WebAssembly, which is really a powerful feature of WebAssembly, is that many languages compile to WebAssembly. So it's a way to make code written in other languages run on browsers. But WebAssembly runs outside of browsers, but that's not the scope of this presentation. So this is how it looks like, a WASM file. So don't worry, that's the only time when you look at this kind of code. And you have also a more readable format just to see how it looks like behind the scenes. And there are a lot of parentheses, but it's not closure. Huh? It's a readable format of WebAssembly. So as I said, WebAssembly allows to, when you have source code written in different languages that compile to WASM, you compile it into WebAssembly, and then this WebAssembly binary, you load it with JavaScript, and you can call it from your JavaScript code. So you have two programming languages, or two ways to run code in the browser nowadays. So as I said, WebAssembly runs also outside of the browser. It's WASM. There was a presentation yesterday from Abdul, if I remember correctly, about this, so please take a look. So to summarize, what's really intrigued me and interested me about WASM is that a lot of languages compile to WebAssembly, and there is this interoperability with JavaScript. So I don't know if you have also this happens to you when you see an interesting technology, you start thinking about different things. So I really wanted to do something related to WebAssembly, but I needed like some goal or some objective. That's where .NET comes into play. So I'm a teacher also, in addition to my daily job, and I teach many different things related to computer programming. One of them is .NET. So .NET is an open source cross-platform framework. Its language is C#, so it's like quite similar in some ways to Java. It's compiled to what we call CLR, which is EL, which is equivalent to bytecode in Java. So I have these kind of similarities. But what's really attracted me is that in 2020, in version 5 of .NET, the BlazorWASM was announced. So it's a component-based framework like Angular, React, and Vue. But the code that you write, instead of writing JavaScript, you write C#. And this C# code is compiled as any C# program, but the .NET runtime, as you can see in this on the bottom left corner, the .NET runtime is compiled or executed in WebAssembly. So this is an example of a Razor component. And you see there is .NET code instead of JavaScript. So initially, I made the port using this technology, but it was really, really intricate. It was not done for general purpose programming. It's really towards component-oriented programming or front end. So hopefully in .NET 7, WASM tools was released, which allows to more directly interact between .NET and JavaScript. So you see here two files, a C# file and a JavaScript file in the same web application. And you see that in C# you can export some methods to JavaScript that you can call in JavaScript, as you see below. And you have the opposite. We define a method in JavaScript, highlighted in blue below, and you can import it in C# and call it from C#, as you can see in line number 6. So you have two-way communication between JavaScript and .NET. So to summarize, Blazor WASM is more adapted to web app and front development, and WASM tools is more general purpose and which is more adapted to the project that I do. And in any case, that's why my game is called BlazorDoom, because initially I did it with Blazor, but now it works with this kind of tooling. So when I see all these features, when I saw all these features of .NET related to WASM, and since I love video gaming, I told myself this is a moment to port a game to the browser, and I really wanted also to try porting games. So that's what made me want to do this thing. So how did I choose the game Doom? So first of all, let's talk about game porting. Game porting consists of making a game run in platforms other than the original ones. There are mainly two ways to port a game. You either rewrite the whole game in the target platform, you write from scratch, which theoretically provides the best performance but takes more time. The other way is to take the source code of the game in one of the ports or in its original platform code and compile it into the target platform and adapt the code. This is faster. If we want to have a port quickly, this is faster. That's the technique that I used here. Of course, using a virtual machine or an emulator is not considered as porting. And as I said in the beginning, I was not confident about making ports. I thought that it was an impossible task to do. But thanks to this video from a YouTuber, which is called MVG. I don't know if anyone here knows MVG. So he's a great YouTuber, gamer, video game programmer, which makes very educative videos. And he was one that gave me confidence about making a port. He made a video where he showed how he ported Heart of Darkness, one of the greatest games of the PlayStation, to Xbox. So why I chose Doom? Of course, does anyone here know about Doom in the room? Yeah, great. So it needs no introduction, one of the greatest games of all time. But technically speaking, in terms of architecture, it's really interesting to port because it's divided into two parts. You have the game engine, which contains the logic, the input-output, the drawing the frames onto the screen, playing the music. And you have the WAD file, which contains the resources, the textures, the music, the assets, the levels, and the maps, and so on. So porting Doom consists of just porting the engine into the target platform. Once you have an engine running in your target platform, you just give it a WAD file and you're ready to go. And speaking of ports, there are many ports of Doom currently available. Official ports and non-official ports. Do you know how many official ports are there? There are 25 of them. In the official ports, from its software or certified by them. And they happen to have 3 of them in the right side of the image. There are Nintendo ports, and I also have Nintendo T-shirt. I don't know if it's related, but and in terms of unofficial ports, there are many of them. Even ChatGPT doesn't know how many are there, so it means that there are a lot, and even a lot of exotic ones. And just to finish with this, do you recognize this person? Yes, it's Bill Gates himself doing an advertisement It was an advertisement about the graphical possibilities of Windows 95, yes, and Doom was used to advertise this. And Bill Gates himself was on the field to make the advertisements. And years later, they bought the company that makes Doom. So, okay, so back to ManagedDoom. So I found the port. I didn't start from the original source code of Doom. I started from a port of Doom in .NET called ManagedDoom. It uses a library called SFML, which handles the multimedia part. So drawing the frame onto the screen, reading the inputs of the player, and playing the music. The current version is version 2, but my work is based on version 1, just to give the information. So to summarize, id Software released the source code of Doom. It's on GitHub. ManagedDoom made a port in .NET with SFML library for the multimedia part and the input-output part. And I forked this repository. I ported this port to make Doom run on the browser. So it may seem a little bit complicated, but you will see that it's not that complex. So making the port, how did they do it? So first bit, introduction about game development. Vast majority of games are developed in this way. You have an infinite loop, which runs 60 times per second, 30 times per second, depending on your FPS. And in each frame, it's an iteration. We get the player input, we update the game state, the position of the characters, the enemies, the bullets, the health, and so on. Everything is updated in this big method, and it generates a frame and some audio to play. So that's the basic architecture of a game. But in JavaScript, there is a little bit, a small difference, is that we can't do a for loop in JavaScript, an infinite for loop. JavaScript, you know, it's single-threaded, and that's not what's recommended. So the recommended way is to keep the iteration, as you can see here. And instead of doing an infinite loop, you do a recursive call, but you use some kind of proxy, which is called request animation frame, which handles doing the recursive call for you. The advantage of using this is that it handles the pacing, so it is called 60 times per second. It's done by the browser. And when you go to another tab or like minimize your browser, the recursive call is suspended. So you get these bonuses by using request animation frame. So let's see in a little bit more detail how I handle the porting. So the original port that I started from is like this. You have a for loop which sends which iterates every frame. It sends some input to the Doom engine, which updates the game state by taking a WAD and a sound font. The sound font is like a character font, but for sounds, like the basic noises or the basic audio. This is called the sound font. So with these two, an audio buffer and a frame buffer are generated. So two arrays, one for audio and one for the picture. And both these are sent to SFML library to either play the audio, play the music, play the sounds, and to render the frame on screen. And this is run indefinitely until we close the game. So as you may guess, the first part doesn't work on the browser because you need to use request animation frame. And the last part doesn't work because, unfortunately, SFML is not available on the browser. It's not implemented. But for the vast majority of the game is 70% OK. This means that when you port the game, I mean, 70% of the work is done. You just need to do like 30%. It's not too much. So that's why it's really interesting to port games, because you learn things and you have results very quickly. So that's the big plan of my porting, is to rewrite the loop in request animation frame and do this kind of multiverse travel between the JavaScript world and the .NET world. So when we're in JavaScript, we call .NET code to update the game state. And when the game state is updated, we send the frame and the audio to the JavaScript APIs to handle them. So in JavaScript, we have audio context to handle the audio, and we have Canvas to handle the frame rendering. So my porting strategy was like not really sophisticated. Clone the repository, run it instead of running using the standard .NET tooling. I used the .NET WASM tooling. But of course, there are a lot of errors because there are many libraries that are not available. There are things that don't work. So what I did was to reverse engineer in SFML. So put empty implementations where it doesn't work with to-do implement. We love to do that. Huh? I don't know if you know. And implement little by little using guesswork and logic. That's what reverse engineering is about. And of course, delegate to JavaScript when necessary. So let me show you an example. So this is the snippet of code from the ManagedDoom source code, where somewhere sound buffer is imported. The sound buffer class is used, and it comes from sfml.audio, so which is not available on the browser. So what I did was just to create it myself. So I recreated this class by adding the arguments that are by reusing the arguments, the constructor, to make it work, to make it compile. And I did no implementation, so empty implementation. Just do this little by little for all the classes that have this issue until I get something to compile. When I see 0 errors, then I'm happy. I'm going to the next step. And this is what I get. This is the final version of the file, just to show you that even when you make things work, when you make the game work, this is the final version of the file. It's not really complex. Just define a constructor, add a field, and you have ported one class into the browser. So do and repeat for all the classes that have generate errors. OK, so we have seen a little bit of code. Now let's deep dive into more code and go darker. Let's go. So since this is a web application, this is the entry point of my game. Of my port. It's a simple index HTML file which has a canvas which loads the .NET runtime. So you see that .NET is compiled into WebAssembly. And it also loads all our C# code which has been compiled into the .NET intermediary representation or intermediary language, which is the equivalent of the bytecode. And we have our main JavaScript file, which runs the game loop. So this is main.js, my main JavaScript file. You see that we have some boilerplate code or some ceremony to load the .NET runtime in this file to get access to it, to import some libraries or some tooling. And we import everything that has been exported from C#. So thanks to this code, the .NET part is available in JavaScript. After that, I run the game loop. As you see, we have request animation frame to do the recursive call. And I update the game state. And you see here, this where I go, I travel to the C# world. This is a C# method defined in the C# side, which updates the game state. And update game state is defined like this. So you see JS export, as I showed earlier. So it's just like an interface to call the Doom engine. And ManagedDoom update game state comes from ManagedDoom. It's the original source code. This update game state method updates the game engine as the game state, as I said, and also draws the frame and plays the audio. How is the audio played? How did I manage to get the audio playing on the browser? So first of all, small summary about audio playback. So you know that audio is a wave, and to store it in a computer, you do what we call sampling. It means you get the value of the wave at each interval, at each fixed interval, which is called the sample rate. So for example, for the part that I highlighted, surrounded with vertical lines, you have the samples that correspond to it. And you store this in an array, what you call the samples, and you store also the sampling frequency. This is computed in C# by the Doom engine. You send this into JavaScript, and give this information to audio context. So it's called the web. It comes from the web audio APIs. With the sample and the sampling frequency, the audio context can rebuild the wave, and you can hear the sound in your speakers. So how this was implemented? So somewhere in C#, inside the update game state, when the sound buffer or the samples are computed, we have in line number 4, we call JavaScript side with play on JS. So it's a JavaScript call. It's a call to a JavaScript method where we send the samples and we send the sample rate. So in the bottom, you see that it's the interface that allows to access the JavaScript method, which is defined in the file render.js and which is called playSound. So playSound is defined like this. I'll highlight the most important part. Here I create the audio buffer that will get a copy of the one sent from C#. I do this because the Doom engine doesn't send the audio buffer sample, how to call it, normalized. So the Doom engine sends the audio samples like values from minus max short, so minus 3200 to plus 3200. But the JavaScript audio API needs to be from -1 to +1. So I need to normalize it. So I create a new buffer just to get a copy, and then I do the normalization here. And then the rest is just some ceremony to initialize the audio API and to play the samples. So that's it for the audio. Now for the frame. The Doom engine generates a one-dimensional array for the frame. It's not already in 2D. So you get, for example, here we have 12 bytes, we have 12 pixels arranged like this. And the value of each pixel is not the RGB value of the pixel. It's a color index. This is a technique that was used a lot in retro games because there was a limit in memory, there was needed to optimize. The number of colors also were limited. So we use this kind of color palette, as you see below, which stores the list of colors that were used in the game, and we reference them in the frame buffer. So, can you guess how will on the right side here, when there is written JS, how will the image be laid out in the JS part? So will it be like from left to right, or how will the frame how will it look like the matrix on the JS side? So left to right, top to bottom. That's what I thought also, but sorry, it's a wrong answer. So the Doom engine lays the pixel from top to bottom and left to right. I don't know why that's how it works. So this is the final result. And initially in my port, I laid the pixels from left to right, top to bottom. I got a very ugly image, very ugly. And this kind of stuff that you don't, to find the, you need to dig a little bit to find the error, but the Doom engine is very well documented. That's one of the rarest times where I needed to read the Doom engine documentation. And by the way, I'm not an expert of Doom engine. That's what's also interesting about making ports. You don't need to be an expert about the game that you're porting. Here's what the image looks like. But one thing that you need to be careful about in JavaScript is that you have a 2D matrix, but each pixel has takes RGBA values. So there is some kind of bit shifting because for each pixel you have 4 items in the array because you have RGBA. So Doom uses color indexing, and the image is built from top to bottom and left to right. So here is how the rendering works on C#. From C# to JavaScript. So similar to the audio, we have somewhere in the Doom engine, the display method is called when the frame is ready. We call render on JS, which is a proxy to the JavaScript method, which is called draw on canvas, defined in render.js. And draw on canvas is like this. It's a simple algorithm which lays a one-dimensional array to a 2D array from top to bottom and left to right. And here is how we apply a color from the color palette to the element in the canvas. So we do some bit shifting. You remember these weird symbols like double greater? So that's one of the rarest occasions where I use these symbols. So I was happy I have learned these at school, but that's one of the use cases. And the alpha is always 225. This is like a constant. No need to bother about it. So it's time for a demo, but you can do the demo. So if you have a recent Android phone with Chrome, just scan this and Android. So it will take some time to get the internet connection, to download the runtime and so on. It works on iOS? I don't know. iOS, Safari, I haven't tested, but it should work on Chrome and Firefox. I'm hearing some monsters shouting. So that's great. I'm not the one who does the demos. It's the public. The stress is on you. It's not on me.
And it works on iOS, apparently.
It works on iOS. Thank you. Nice. So of course I have a newer version with sound. So I hope it works. So here you go. Let's speedrun the first level. Let's go. And let's also push the frame rate cap. So here's how fast it can go. The fastest speed. Okay, let's speedrun. Speedrun. Done. Yes. Thank you. So okay, the audio should stop. That's advantage of a request animation frame is that when you switch tab, it stops running the game engine. The max FPS for request animation frame is 60. It can't go further. Maybe it will change over time, but okay. So next steps and conclusions. So next step is to improve the background music. So you didn't notice, but there are some synchronization issues with background music. It's not like very critical, but that's something maybe I can work on to improve. Also to update to ManagedDoom V2 because it's the latest version. So, and maybe why not make this port as an official part of ManagedDoom repository. And the key takeaways is that WASM possibilities are limitless. As you have seen here, I spent 3 times as a side project to get this working. 3 weeks. The side project during evenings, weekends, and so on, to get this working. And porting a game, as said during one of the keynotes, porting a game is great and fun way to learn programming, and I testify on this. So thank you very much for your attention. Here are the slides, the source code. Please keep in touch with me, and thank you for watching. Do you have any questions? Yes?
First of all, thank you for a great demo. Very fascinating, and I'm wondering, like, as I understand correctly, this is a purely CPU accelerated game, right? So it doesn't use GPU acceleration. And how feasible would be to port some old 3D game?
Yeah, so that's a good point. So the frame is computed with the CPU, and then the rendering is done on the canvas. So maybe this is handled by the browser, so it's optimized. This part is optimized. What can be optimized is how to generate the frame buffer. This, in terms of optimization, maybe it can be done with the GPU. So in that case, we need to also deep dive into the code, and when the Doom engine, the software renderer takes place, we replace it by the web GPU, for example, in the web. But that's but there, maybe we can ask the question: shall we rewrite maybe the whole thing in JavaScript? You see, that's a great question that you may ask. That's what's also interesting about game porting. At which moment we say that we write from scratch, or we just keep modifying the existing source code.
Okay.
Did I answer your question?
Yeah.
All right.
Thank you very much for the talk. It seems like a monumental effort that you've done. I can't believe it only took 3 weeks. But I wanted to ask you a question about how did you manage intermediate progress? So you mentioned that you just took the library, sorry, I forgot the name of the library.
SFML.
Put
Yeah.
the empty implementations and
Yeah.
waited until it compiles.
Yeah.
So how long did it take you to actually get the first feedback when you understood that your effort is not the way, that you won't have to implement some really complicated functions that you just mocked and left the implementation empty?
Yeah, you know what? The feeling that it's a very interesting question. Thank you for asking. So it was like going to an adventure. I had this feeling that it's a side job. I want to experiment, so I go to the adventure and remove classes until I find something. But hopefully, the original port, like the ManagedDoom port, is a very clean port. Like the folder structure is clean. The SFML bound part is not like spaghetti code or not dependent on the other side. So the code was originally very clean. So and on my side it was like adventure and trying, be patient, little by little. And I didn't know how much time it will take me, but like maybe 2 or 3 nights, something like this, to get something working. Of work. You're welcome. Okay, time is up. Thank you very much. I'm here around if you have any questions.